Does it work? Yeah, my secretary will bring you on.
Yes.
All right, welcome everybody. IETF 92 in Dallas, and this is the DMM working group meeting. First couple of things, so we will meet this week twice, so today and then Thursday again. Today we only have this quick slot for 1 hour with 2 presentations, and then we'll continue with the rest of the stuff on Thursday. You should be aware of the note well, so if you are not, go to the agendas and familiarize yourself with the note well material on that we have attached to the agenda. I already put the blue sheets going around, so put your names there. And so for today we have basically 2 things about the kind of reports from the working teams and working team leaders, describing the status what they have achieved since last IETF 91. So exposing mobility state is the working team 1, and then the enhanced anchoring. And this is basically all that we have today. And then on Thursday we will continue with the working teams 3 and 4. After that we have the ones of the within the charter, but the individual work that people want to present. All right.
I think we need a mini taker, right? Yeah. So anyone want to volunteer?
I can also volunteer someone out of the. I see there one. John, excellent. Thank you. And is anyone in chapter? So, Peshat, are you going to be in chapter? Okay. All right. Okay, try. Okay. Good. All right. So let's get started. So the just a bit of background so that the those who haven't been following DMM. So we have our base RFCs done now. All are out, and the now the working teams are kind of working towards their solutions, and most likely these working groups are also at some point of time going to propose some individual drafts that then we handle like any other individual ID, and out of those, like whether the working group decides, we can also then decide select the actual working group items to work on. So the first thing, Albert, are you here? Outside. Of course, he's our like a star for today. We need to spank him a bit, like being late. Maybe we start with the... Or Anthony, are you ready to go? Anthony?
Yes. You want me to go first?
Yeah, because the...
Okay.
Seems that Albert is somewhere lost in translation.
Other slides.
Yeah, I have those. Let me do the magic thing.
This is a report from the Enhanced Mobility Anchors work team, and there are two teleconferences from the last since the last IETF meeting in November and January. And the next one, in those teleconferences, there are a few presentations, as listed over here. The presentations are already sent out in the minutes with the files of the presentation. It includes the moving network, the AAA, using AA moving IP address, and then there's one more presentation to be arranged later. And the next slide. After seeing this and after reading all this, and in addition to all this, there were also a number of draft proposals that were presented prior to the formation of this team. And so we should also take them into account, and there were quite a number of different proposals. So when we look at them, then this is the charter of the working team. That's the charter, and from the charter we are supposed to define the solution for the gateway assignment and for the midsection, change of the section. So when we go to the next slide, at that point, we are losing the top line, but it's okay.
Yep.
We went to the question of how to harmonize all the different solutions, and because the different solutions some of them are complementary and some of them are quite different, so we tried a way to harmonize them. And then there's a function which is already defined, is the anchoring function which was defined in 7429, and that's the only one defined. The anchoring function is basically to anchor the IP address to broadcast that address. And the next slide, however, there are many other functions of the anchor that are some of them are there, some of them are not there. And in order to try to take them into account, the next slide is trying to distinguish the anchoring function of the IP address, to anchor IP addresses, versus the bottom one is to anchor the section. The top one anchoring the IP address is probably found in almost every solution. You're anchoring. So the question is, what are you anchoring? What are you actually anchoring? And anchoring the IP address is obvious, but the other one is to anchor the section, and we normally put them together as a single mobility anchor or separate. But if we go for the two solutions, we can ask more deeply what are they anchoring, whether they are separate. Now, if we separate them, anchoring the IP address is obvious, okay? And then anchor the section. When we talk about section, we usually think of it end to end as the two end. However, if you put an anchor, so this is something that you're trying to get it passed through. And there are scenarios in which they are distinguished from each other. So I'm going to go through some of them. The next one. Suppose you are anchoring the IP address only, okay, so it only have an IP address. Then there are scenarios in which you use the IP address of the network. So the mobile window is on. You have two network, net one on one side, net two on the other side. The network anchors the IP address one and level 2 anchors the IP address 2, and you can, the mobile node with an IP address of IP2 could be running a section which is using, the section has the IP2, so it's using it. And the next line is that exactly the same thing, except that you are using an IP address not of the network. So the section is IP1 on the right-hand side. Everything is the same except that the IP2 is using a section identified by IP1, which is not in IP2, so it's not in that section. That would take care of a lot of for example, Alpha was looking at a scenario in which you are using an address which does not belong to the network. Okay, so and then the next line is that so it's not the mobility. You want to keep the IP address in the midsection. So IP1, and you move to a different network. As you move, you're keeping that IP address. But if you keep that IP address, you need to have some mobility protocol to do it. So this is not in the scope yet, because this is an IP address. In the next line is that we are missing the top line. We are changing the anchoring of the IP address. So the anchor was in the left-hand side, moving to the right-hand side. So you change it, and then you change IP address. So that's obvious. That's section 1 and then section 2. And the next line is that you're doing exactly the same thing as before, but you don't want to change IP address. So if you don't want to change IP address, one possible thing is to actually move the anchoring of the anchoring function from the network 1 to network 2. Okay, you move the mobile node move to net 2, but the anchor also move to net 2. So as you move to net 2, so the routing will be taken care of. So as you move, okay. Moving that IP address is an example is by using prefix delegation, which is used in NIMO, another protocol. We just do a prefix delegation, and then the whole IP address belongs to the other side. And then
so prefix delegation, you're assuming it's initiated by the client. How are you delegating the prefix? Is the client DHCP v6 PD capable?
No, not the client.
So when you say DHCP PD, I'm trying to understand how you're using DHCP PD here.
It's not from the client. It's the prefix delegation from the anchor to the other anchor, from one router to another router. This router.
Okay, so you said NIMO.
Yeah. IP1, okay. Owns IP2, so that two subnets.
So what is the protocol they're using there?
Such as the prefix delegation. It's one example, or you use SDN, or use a control pan.
Sorry.
There are different ways of doing it. Okay. If you use the control pan, then it would be. So far it's all anchoring the IP address. We didn't do anything with the section.
Yes, please.
Try to lower it a little bit. Lower a little bit so that you can see the top line. Yes. First of all. Now next we are going to talk about the anchor of the section. The anchor of the... Huh? We still have the anchor of the address, but there's a separate anchor of the section. You anchor the section or the flow or whatever we define later. For example, this is the section of the anchor of the section. So you anchor IP address so the flow will move over there. But then the anchor of the section, the anchor of the address cannot do it because it's anchoring the address. But it's the anchor of the section that changes, put a tunnel to it or do something to it, and put a binding to it that will redirect the traffic to the other side. So there's an anchor of the section on the left-hand side and anchor of the section also on the right-hand side, in addition to the anchor of the IP address. Okay, so this is the basic of the anchor of the section. So in this picture, they are in the same, they're co-located, but they do not need to be co-located, and we'll see that later. So we go to the next slide. In this slide is basically the route optimization, what people normally talk about route optimization. The section anchor and the IP anchor and section anchor of the IP and anchor of the section are in the same place initially. But then you move the anchor of the section to the CN's network. Okay. So this is the packet as we go through anyway, because this is anchoring the IP address of the CN. So if this anchor move over there, so this anchor is gone, but the IP anchor stays there because this IP address is still there. So the IP address would have come over here, the packet goes to there, but the section anchor is redirecting the packet, such as we write header or to encapsulate it, redirect it to a section anchor.
Yeah. Just a quick note. So you are supposed to stay in that red area for the Yeah, I know.
One quick question. I'm having a tough time in following this, right? So what is a session anchor? What is an IP anchor? Is IP, so what I understood is you're putting a host route or not even a host route, you're routing a specific IP flow through one path, and you're still keeping the mobility session on a different anchor. Is that what it is?
Are you talking about
this entire discussion
definition of the section anchor?
Let's take this. This moving session anchoring, yeah.
There was a slide somewhere before on the definition of the section anchor. The anchor of the section means you try to cause the traffic to go through at least one of the section anchor, at least one, not all. For example, if you're using any cast, then it will only go through one of them, but not all of them.
Okay, maybe very simple question, right? How is the forwarding plane in the IP network able to steer one particular IP flow on one path and all the rest of the flows on a different path? Or are you assuming that there's a flow-based stitching in the IP network? Are you making flow-based forwarding decisions?
I'm using the term section and flow probably mean the same thing for the time being. Okay, so if there's a flow, whether you want to call it a flow or section is up to you. So there's a flow. The flow is going from CN to the new position, and you cause the flow to go up, go to the section anchor, and redirect to the other section anchor. So this IP is still there. You didn't change the IP address. So it's trying to get the packet, draw the IP over here. But the section anchor has moved it elsewhere. So the dotted line is not there anymore.
Okay, I'll not take much time, but maybe a call flow would have helped actually. So.
Call flow is better? What? No.
Marco Liebsch, just a clarifying question. Can you go back to the previous slide, please? Just for this case and the previous case. So in this case, that's the most obvious and pragmatic scenario. And here, the mobile node keeps IP1, even though it moves to the access router anchor. But access router 2 is not an anchor at all in this scenario, right? So the anchor 1 remains the anchor and forwards the packets to the mobile node's current location.
On the net 2, that anchor is anchoring the IP2, not the anchor 1.
But mobile node has only IP1.
Mobile node has an IP address of IP2, but it's running a section which is identified by IP1.
Okay, so the mobile node has two IP addresses, IP1 for the remaining session and IP2 for the new one.
It moved over there, so the IP address of the mobile node has changed to IP2, but it's running a section identified with IP1.
Okay.
So you think of a mobile IP scenario in which you use a dynamic, you dynamically change it. So, for example, you can have a new set.
So you renumber the host, right? So you renumber the end host, mobile node.
I think IP1 is deprecated but still used for the running session.
Okay, so okay.
And the previous one, page 11?
Previous one.
I think the difference is that the anchor has changed, right? So the new anchor on the right side now anchors IP1.
This one doesn't have the section anchor. This is not anchoring the section. This is anchoring the IP address only. And it moved the anchor of the IP address to the other side. So the IP address belongs to the new network now instead of the previous network. Okay.
And the
so it would
arrow
just route naturally. For example, SDN, suppose there are two subnets. The SDN controller say that, oh, from now on, this IP address belongs to that node. It belongs to this node, now it belongs to the other node.
I think this tries to capture what we discussed in the past many times, and it's a valid use case. I'm just trying to understand the figure here. And
it is trying to capture a lot of the different proposals in this scenario, in different scenario.
All right.
You know, I think just to add to that, right, I'm not following this. In the past, what we talked about was, everybody agreed, we talked about session re-anchoring, right? Essentially, starting point is a client gets an IP address or a prefix, whatever, that subscriber session is anchored on a node. How we move that subscriber session along with the prefixes addresses to a different anchor point, right? We talked about that interactions, and we also talked about a prior work, which was the global AHA work, which was done many years back. I thought, or at least many people thought, we are going to bring that work back into life and leverage all of that work. But this is completely going in a different direction. I'm not following how it aligns to what we discussed in the past.
We had a definition of anchoring function, which is defined in IETF 7429. I mean, we do not have any definition of mobility anchor in any RFC. The only definition is an anchoring function. And we usually talk of it as an IP, and that function is on an IP address. It's basically to advertise the prefix for that IP address. That's what we have. And that part is not enough. I'm saying that part is not enough. That part is only anchoring the IP address. And that's also what we normally talk about anchoring of a section is different from the anchoring of the IP address.
What is a session then? What is a session in your terms?
A flow.
Flow? Flow is a session? It's a TC application session or a mobility session?
An application could be running, you have an ongoing section running as you hand over, and you are trying to get section continuity. Is the type of section you're talking about?
Maybe there's a mix-up of terminology, I don't know.
Kent Leong, just want to clarify your session. I think that's the point of confusion, right?
Yes.
It sounds like to me what you're saying is that you have an IP address, right? And then you have some kind of session/flow, which is not specific related to the IP of the mobile device, right? You have a session almost by itself that can move. That's independent of the IP address that the mobile device owns. Is that right? The way you're showing, for example, IP2 for MN and IP session with IP1, but it doesn't own the IP? Is that what you're saying?
Yeah, let's go back to the definition. Go back about 5 or 6 different slides on the definition of the two definitions. This one. The anchoring of if you anchor the IP address, is basically advertising a prefix, so that's clear.
I think everybody knows that part.
If you anchor the section,
Yeah.
that means you're trying to cause the packet associated with the section of the flow,
Exactly with the flow.
to go through at that point.
Yeah, I think there's a lot of confusion or issue with that, right? One is that on the mobile side, does the mobile still own the IP address where the session is targeted for? That's one question. And the other part is the transport of that flow to your anchor. Is it through the routing topology, or what forwarding topology allows that to work, right? So maybe there's 2 points that is unclear. Maybe, I don't know, maybe it's in the draft, but I think that if you can clarify that, that would be helpful.
Let's go back to the previous slide. Go to up the slide. Go. Basically, there are lots of different ways to do the mobility. You can, and some people call the anchor. Is it the way that the packet is going through it, or whether you can use interaction tunneling or some of that, or do some of these actions. So there are different methods that the anchor of the section can do, such as to redirect do an interaction, do a tunneling, encapsulation, decapsulation. Though these are the functions that the anchor of the section could do.
Okay, I got that. So for the session, you're saying that you can different methods. Routing is, it's not a flow level, right? I can see you doing tunneling, but that still requires somebody to set up the tunneling endpoint.
Tunneling interaction basically are similar, right? You rewrite.
Yeah, that's what I'm saying. That for tunneling, I think you can do that, but for routing, you're not routing at a flow level, right? You're saying all these different four ways are ways of doing it. But anyways, it's okay. I'm just trying to understand. It doesn't quite make sense to me, I guess, at the end of the day. So.
Now we jump for about 5 or 6 different slides. Now this is all. I think this one is the anchoring of the IP address only. It has nothing to do with the section. Okay. It is anchoring the IP address only.
Okay.
It doesn't have none of those functions. And it's basically move the anchor to the other side. Okay. So the traffic will flow. Okay. So this is this scenario didn't touch on the section anchor. And then go to the next slide. And this one is a typical mobile IP scenario. Okay, we added a section, the anchoring of the section, the red box on the left-hand side, and the red box on the other side. This is a typical PMIP scenario. Okay, because this one does the tunneling, it keeps the binding and so on. So it has a binding of the section using IP address 1. This binding over here in red is pointing to the address of the access router on the right-hand side. Okay, and the next line is that I'm moving the anchoring function of the section in network 1 to network 3. So this one is gone. Okay, this box is gone, but this one remains. The anchoring of the IP address one remains. It still advertises the prefix, but the packet will not go there because the anchor in the section had already intercepted, you already tunnel it, and then it goes directly. Okay, so this is a typical route optimization scenario. Now in a route optimization scenario, the anchor of the address didn't change, but the packet doesn't go to that anymore. It's still advertising, it doesn't go there anymore, but the packet will directly go to the other side. Okay.
Route optimization is different because if you look at the way route optimization is working, the care of address and the home address are still present in the packet headers. It's the way use of destination options header and with other magic it's happening. It's not that you cannot take route optimization as an example and relate to this.
I'm just giving it as in a high level, okay? Because this is not doing that not exactly following that, but it's just giving it as an analogy, right? You're right. It doesn't use because there are different proposals. I'm trying to harmonize all of them by. And if we try that, it seems to me the different proposal can be captured.
See what, I'm having a tough time when you say there is a session here on one anchor, but the IP address or the addresses associated to that session is on a different anchor. What does it mean? What does that session mean there? Right? So.
No, it's not a section. The section doesn't move. It's a packet associated with the section. is going to flow through that point, that node. Okay.
Okay. Right. So. Right. Okay.
Any other questions?
Yeah. Okay. Anyway, so you probably noticed that you have a problem with your terminology, so people don't really follow what you mean in certain points. So anyway, so that's the place kind of to add more some clarity about this. Or then the people didn't read the notes from the previous interim meetings. Anyway, so
we can discuss further in the mailing
yeah,
list
definitely, and bring this like the more clarity what you mean about this session, and when you actually see it move to anchor function, but you are still advertising the existing prefix. So if you can describe that with the existing technologies or similar technologies that we have today, that would basically make it easier to understand what.
The picture is not clear?
Hmm?
You mean the picture is not clear or what?
Yeah, I mean, so like this one, you could basically say that now the anchor function moves to the other one, right? In this one, so like you are yeah, but you are like you still have the router there that can be an anchor for new mobiles attaching that one, but for the existing session our route optimized from this net 3 to the other one.
Right.
So if you can describe that like how you move the what is the mechanism to move the existing session anchoring to the network 2 and so on, so that would basically clarify that.
Let me try to use language that people normally use. Okay, you basically intercept the packet net 3, intercept the net 3, and capture it or redirect it to net 2. Okay, and that function of intercepting and capturing it and decapsulating and so on, I'm calling it you are anchoring the section so that the packet goes through that.
Okay. All right. Thank you, Anthony. So we'll continue the discussion on the mailing list on this part.
Anthony, do you have a draft as the design team output?
The draft is in the internet.
Okay.
Yeah, you can read the draft and please send your comments in the mailing list as you go through the draft. Thank you.
So is the draft is the consensus of the design team?
I discussed with a few people already. Yeah.
You mean you have discussed the draft during the teleconference and the people in the design team agree on that, right? Or it's just your individual document?
Several people have checked the draft and they have actually made comments on it already.
Okay.
But we are open to listen to more inputs and comments.
Okay, thank you. So let's move for the working team 2. So Albert, state it's yours.
Okay. So this is the report from Mobility Exposure and Selection Working Team. Next slide, please. So since last IETF, we held 2 conference calls. In conference call number 3, you see the date, the attendees. The agenda was to discuss the item number 1 on our plate, which involved defining a DMM API between the applications and the IP stack on the mobile node. And for that, we had 2 drafts on the table. You can see the notes on that link, which I will quickly capture in this presentation. Next slide, please. So basically for item number 1, in earlier meetings, we had identified a number of principles. Basically, we had agreed that we're going to define an extension to RFC 5014, which is the source address selection algorithm. And the baseline RFC already has 2 flags, but we recognize the fact that we need to have 3 distinct flags in order to achieve our objectives in this working group. And we defined 3 different types of IP addresses for that: fixed IP address, sustained IP address, and numeric IP address. We had also identified that the solution must trigger dynamic IP address configuration if the desired IP address type is not already available on the IP stack. And so based on this, we have looked at the 2 drafts in that call. Next slide, please. The first draft, the check marks. Well, anyways, it does work with the RFC 5014 framework. It does define those 3 new types of flags, and also covers the case when the requested type IP address is not already configured. It has the hooks to go and configure them and make them available to the applications. So this draft satisfied those 3 principles we had identified early on. Next one, please. The next draft, it's also based on extending RFC 5014, but it only defines 2 flags, not 3. And we couldn't fully understand the semantics of those flags. The authors were not in the call. We welcome further elaboration on that. Nevertheless, it's obviously missing the 3rd type, even with the right semantics. And there's also no notion of dynamically configuring the IP address. Next slide, please. So based on that, the working team agreed to propose adopting the first draft as the baseline for the DMM API. And as part of the discussions, people also brought up a need to capture backward compatibility. And Danny Moses proposed text for that, which we have already incorporated into the version 03 of this draft, to capture the case of mix and match between the application, what it supports, and what the host stack and network supports. So the working team is basically proposing working group to adopt this draft as the baseline. And I have, well, we have captured that on the meeting minutes, and also last week or a week and a half ago, I have sent an email on the mailing list indicating our intention to propose that. So either right now or at the end of the presentation, I'm hoping the chairs will ask that question to the working group for adoption. You guys want to do it now or at the end?
Just go to the end and then we'll check.
And okay.
This is W. I make these comments as individual. So I have a fundamental question for your proposal here. So what's this proposal? What's the relationship between your proposal and the DMM? It solve any problem in the DMM charter?
Yes.
Yeah, that allows, for example, do the on-demand use of mobility. That's one thing.
Yeah. Well, I mean, Dapeng, you're just taking us back to a year ago. I mean, we have been going through this exercise of...
No. I agree.
Maybe I misunderstood your question.
Yeah, I agree with the charter that we have a work item to explore the mobility state. But when I reading your draft, your proposal, it seems it doesn't solve any problem. You have some extension. Yeah, previous slide, please. No, previous one. Yeah. You have some extensions of the. You define some new flags, but how do you use that? You don't mention about that.
It's in the draft. What do you mean how you use that? The draft describes those flags. It just doesn't say these are the flags. It says the applications who needs that should use that flag, and this is how the stack should behave.
Yeah.
This is along the lines of RFC 5014.
Okay. You mentioned not the application how to use the flag, but you don't mention what's the problem you solved in the DMM scope, right?
I think you're talking about something that we had gone over at the previous IETF. We have shown how this item fits into the charter. So if you're asking if this fits into the charter, we had already addressed that in the previous IETF meeting. So maybe you pull up the slides from the archive, and then we talk about that now. I mean, we have passed that point.
Yeah. I don't have any problem with the charter. I agree with the charter, but I think there is a gap between your proposal and the charter item.
What is that gap?
That's basically my concern.
Yeah, can you tell me that gap, precisely what that gap is?
Okay. So I think the proposal, you have 3 more flags about the IP address, right?
Mm-hmm.
Yeah, 3 more flags. How it's called fixed, suspended, and nomadic, right? But is there any solution related to DMM? How to use this?
I'll let
flags?
other people help me.
That's my concern.
Question, so.
Yeah, maybe, I'll jump in, right? So Depeng, this is the enabler from the, we made some assumptions for the DMM solutions, right? We made certain assumptions, right? For, avoiding, essentially to avoiding host routes or whatever reasons, right? We thought for avoiding tunneling or other approaches, we thought DMM is about, smaller cells, the ability to, for the client, wherever it anchors, that becomes the, the local gateway becomes the anchor, right? Later it moves, when it moves from that anchor to a different location, the idea was to enable the client to, get a, obtain a local IP address from that network, and over time phase out the address from that it was using the previous network or previously where it was anchored, right? So the client at a point of time has multiple IP addresses, right? But it doesn't know which IP address is what, right? Now with this work, we are enabling the client to be more intelligent, right? It's essentially, enabling the applications to be more intelligent. Right now that awareness is not present, right? So this is fundamental to from the overall solution point of view.
I agree with the scenario that you described and the solution. I agree, but I don't agree with the flags you propose here. So how can these flags used to solve the problem that Sri just mentioned? Can you give us one specific example how this works?
Did you read the draft, Dapeng?
Sure.
Okay, so in the draft we clearly explain through these flags the application can indicate what type of an IP address it needs. Okay.
Satisfies the flags. Who executes the flags? Is there a DHCP option to obtain a fixed IP?
Guys, I don't think you guys are following these discussions carefully. I gotta tell you. I mean, we have broken down this problem into pieces. Okay. One piece is how the application indicates its intention to the stack. This is that piece. Another piece, which is not in this draft, is how the IP stack on the host acts on it.
Yeah. So
that's another piece. I mean, we have shown all the breakdown of these things in the past. I have a strong feeling people are not following this work closely.
Yeah.
And I'm kind of tired of repeating myself.
There is a draft that we are going to present on Thursday, which is an extension to DHCP to support these flags.
Yeah.
So, yes, we are working on the whole solution. We broke it into different drafts. There is a reason for that, because here we propose extensions to RFC 5014. The DHCP extension is an extension to the DHCP v6 RFC. This is why they are separate.
So we're not going to solve the DMM problem in a single draft. I hope people realize that.
Yep. So just to clarify, so what Albert is presenting is just one enabler of the whole set. So we need the network to host part. This is from the application to stack part.
Yes.
So it's just like And then this what Albert is presenting is then independent of the actual network to host communication, how you realize that, whether you use DHCP Slack or whether it's a mobile IP or something else, like whatever signaling there is, iQuestion to pick it, but you still need for application some tool to indicate, like I want to have cars instead of boats or whatever. And we currently 5014 already has the concept of COA and home address, right. But that's purely from the mobile IPv6 point of view. And now in the DMM we have the kind of thing like this, some addresses are okay to go, and we want to know a bit more about what kind of address the application is going to ask for. So that's where it's heading to.
I just wanted to understand, Peng, were you satisfied with the answer to your question, or is this still open?
I think it's still open because I don't think these three flags can solve all the problem of the dynamic anchor. That's my personal
let me try
opinion.
and answer. First of all, it's not supposed to answer all the problems that we have. What we talked in the past and we identified is that if you think about supporting mobility and anchoring, there is some overhead in the network in order to support anchoring, either via host routing or via some tunneling and things like that. And another thing that we detected was that some applications don't require this overhead. For example, some applications won't break if the source IP address changes while they are in session. So what this draft proposes is to identify various types of services that are required from the network, the three types of services, and proposes that the application convey to the IP stack what type of service they require. And then the IP stack, through other means, will communicate that to the network, and then the network will know to allocate the appropriate resources for those specific applications. This is what this draft is about.
Yeah. So in general, I agree with the general idea, but I don't agree with specific solution here. So that's my point. And
Okay.
another thing I want to mention is that we should also solve the dynamic anchor problem. I think Sri has just described that scenario. I don't think this draft solves that scenario.
And it's not supposed to solve this scenario. It only is trying to resolve the ability of an application to convey to the network what its needs are. And if you don't think it's a good solution, please propose a different one, and then we can compare.
Okay. So, Hopper, you have 10 minutes. So, do you want to complete the set, or you have specific clarification questions for the for this slide or previous slides?
I have comments.
Okay.
Two comments that may
Okay.
take some time. Okay. I don't know how much time here. Now, the first comment is this. I am aware, I think, of almost all IP address auto-configuration mechanisms at IETF. Okay, I have never heard of one, or I don't see a parallel of this requesting a kind of IP address. Like, for example, here, I agree with this. This application requests something to the stack. I agree with that.
It does exist, you know that, right?
No.
C5014 has that.
Yeah, I mean, yeah.
We didn't invent that notion.
What does it have?
Can you move up, down, up, what?
Yeah,
up,
yeah.
Up, stuff.
Yeah.
So
Yeah, yeah.
RFC already defines that
Already,
notion.
yeah,
I mean,
okay,
we
yeah.
are not in the creative mode here. We're just in the extended
Okay.
mode.
This RFC has these two options. Did you see address auto-configuration protocol that satisfies this?
Alex, we just said that this thing is not going to solve it. There's another work that we need to do between the network and the host to bring that prefix coloring information, for example.
Prefix coloring.
Yes. That
We
kind of
had prefix coloring work. It didn't go anywhere.
No, it's going to come back here. That's the point. I mean, this work will plug into a solution like prefix coloring. That's the top part, the API part. The bottom part is in progress.
I don't know how to further explore it, just express my skepticism that I don't think a address auto-configuration mechanism has this parameter like requesting a kind of IP address. You never request a kind of, you just request an address.
You don't really need to request a kind. For example, when the network provides an address, it can say that this address has these properties, like it's going to be anchored, and then the stack, when you ask, if you ask for an address that has an anchor and the address that was given you from network doesn't have that information, then this query for binding to that kind of address, it fails in a host.
Can you give me an example of some router that offers this address?
There is no that kind of stuff yet.
Yeah, it's work in progress.
And you are confident it's going to happen?
Well, we're going to propose those as well. So these things will plug in together.
I agree that if, for example, the HCP working group or some router or Slack or something gives a type for an address in that mechanism, then this API makes sense.
We cannot do things
But
instantaneously.
But
right?
I think this those two things should be progressed together.
Yes.
One depends on the other. So you cannot make a last call now on this.
It's not a last call, it's a
That's
working
what you asked.
adoption.
So
It's a working group adoption, it's not a last call.
Alex, so
Adoption is the same thing.
so
No,
Alex
it's not the same thing.
and Albert, so there will be more stuff on Thursday on this same topic. They just don't fit in the same presentation.
Okay, so let's take it to Thursday. This,
So and when we were creating this our charter, we discussed the same thing through back then, and we agreed that we need to have this network to host protocol to carry information. So it's just like tackling one task at a time.
Yeah. Okay.
So we don't have those mechanisms in place yet. There's a related work going on otherwise that we can, for example, plug into or just go and do our own stuff. So.
And regarding these things, these
You
are like
also have
Lego
to think
pieces.
implementation, yeah.
These are like Lego pieces, okay? They can all click in together,
Yeah.
but that's not a gating factor for working group adoption. But that would be a gating factor for like publication. I mean, if these things don't hold up, we can always drop things. But for working group adoption, we don't have to wait for all pieces to be lined up.
We already, the two options that you've shown are already specified in an RFC and are not implemented in operating systems, okay? For example, you say if config today, you don't see that address being a home address or a care of address or particular type of address. All you know, you have the address, that's all. And maybe it's prefixing, that's all.
Okay.
So these are things specified in RFC 5000 something, several years ago. It's not implemented. Are
That's
we going
fine.
to do the same thing?
Are you sure? Have you checked the latest Linux kernel?
I'm checking it. Yeah.
Okay.
Yeah, I know. There is no longer this notion of experimental. So yeah.
Anyway, you can ask for it, but the kernel doesn't provide you the proper answer. So you have the headers in place. Anyway, so
Okay.
we are running out of time, so we take.
That was the first comment.
First.
Yeah, I have a second comment. I have not read the draft, but I think this kind of thing is for the application running on the terminal, right? On the mobile host. Is it right?
It can also run in a mobile router.
I think the applications don't run on the mobile router. Okay? So if so, then I think we should specify it in the document.
Okay.
The application,
What exactly on the document?
that this API is for a mobile host
You
only.
can run it on the router as well. I mean, if you
Yeah,
have
but
an
the
application on the
applications-
router-
Yeah. Okay. Right. Point taken. So
Yep.
next one. So Marco has been less than you there in the line. So.
On your comment too, right, we do run applications on mobile routers today, like IPSLA. Come on. So on point number 1, right, between the, I think there are 2 parts to it. I think I just want to repeat that, what Alper is saying, right? Essentially, allowing the application to be aware of the address property is one thing, and then allowing the host to obtain a particular type of address from the network is another property, another aspect. That is both on DHCP v6 and on neighbor discovery, right? We proposed extensions, right? There is some work that happened in MIF. I agree. There was, we published this some time back. It made it, there was some, because of some other work in DHCP, it took a slow track. Now that we have a proper use case and a motivation, we should be able to, those documents on a mature shape, we should be able to move them on a fast track. So the linkage is there. Now with respect to other comment, if 50/14, some socket option is not implemented in some Linux kernel, that has nothing to do with this discussion. We are on a standards thing. Implementation is, of course, our motivation is to get implementation, but that does not mean anything from the point of view from this discussion.
So just a brief comment, which is not criticism, but just something you may take into account for the further discussion. So nowadays, when you program applications, you have the means to bind the traffic to a particular interface or IP address. So I see the value here in that you simplify this, that the application just says, I need this kind of IP address, and the kernel takes care of the rest, right? So you mentioned here, if, for example, an application requests a nomadic address, the kernel takes care about configuring one if there is no nomadic address, but I'm not sure if this overcomplicates the whole thing. So if there is an application which just sent an HTTP request expecting one response, so for that request to configure an IP address, but why not just using one of the existing ones like a central, how is it called?
Sustained, fixed, nomadic.
Or the fixed one.
Right.
So where is the gain and where is the proposal overcomplicating things, and the gain is actually really
if the application doesn't care, then it doesn't use any of these flags, and then that's the legacy behavior. But if the application has a certain need, like it needs sustained IP address, then it has to explicitly indicate that. Otherwise, it may not work, right? I mean, it's hit or miss.
How can the application decide? Is that kind of
it's
fixed?
The developer knows that. The developer of the application knows the intent and how the application is supposed to behave. You would know if you're writing a video streaming client or a chat client or a DNS client, and you know what it really needs. Whether it needs a sustained IP address or a fixed IP address or nomadic, then you use the right flag.
Okay, so Albert, just do you still want to continue with your presentation because we are running out of time?
Okay, I can capture these last two slides.
Okay, so
can also
we can continue this discussion like on the mailing list and whatever. So.
Okay. Well,
just
one
go
more
on.
Conference call. The agenda was to discuss principles for item number 2 and 3. Basically, these are the items for our working team to describe how the IP configuration protocols are extended in order to support this IP address types. Okay, basically, network at the time of configuring an IP address or prefix on the host should have a way to convey the type of the IP address or the prefix. Similarly, the host at the time it's requesting an IP address, it should have a way to convey the type it needs. So we've gone over a bunch of IP address configuration techniques, we recognize, we basically identified the need for extending DHCP v6, stateless address configuration, mobile IPv6 and IPv2 in order to plug in the bottom part of this API, okay? Right now, the next steps is to, we open the floor for people to propose solutions for that, those items, and we have one that we will see on Thursday.
Okay.
That's it.
All right.
Oh, the item number 4 is about describing how mobile node decides between IP layer and other layer based mobility support, which we didn't have any progress. We will discuss it in the future conference calls.
Okay, thank you.
Okay, Xin-Peng my first concern is that you like what you do define 3 kinds of IP prefix. I'm afraid the application developer may be confused about the prefix, and they will seldom use this kind of prefix. And my second concern is that is the definition of the IP prefix and socket option should be done in DMM work group or in other IP related work group.
Oh, okay. I didn't understand the second one. The first one you were saying the people may be confused.
Yeah. I believe most application developers, they don't care about the network address. Yeah, they just want to develop their application. So if you provide several kinds of IP address, they may don't understand what mobility is.
Right.
Yeah.
So well, that's why we documented here. So the applications that wants to have efficient networking through DMM techniques would adopt this API, which we're going to document. There will be white papers, presentations, and education and all that. So that's what an API takes to get adopted in the field. So hopefully people will read and understand them correctly. So
okay,
that's the cost of
we first
extending
educate people, and when they develop the apps. And my second question is the prefix definition and the socket option definition be defined in the DMM work group or in other IP-related work group of, for example, 6 months?
I mean, this item number 2 and 3, this is something that we will need to discuss. I mean, proposals probably will be considered here first, and then they may be taken to respective working groups. But again, this is my personal opinion. Chairs and the AD may have a different opinion on that. So, but at least they will first be discussed here to make sure we got the semantics right. We may not be the final authority, but they must start from here.
All right.
Okay, thank you.
We are over time, so if people want to stay here, feel free. I will leave at some point of time, but you can continue. Anyway, so
the working group adoption.
We'll take that on Thursday. After we also hear the maybe people have better better context in that case.
It would be good if people read the draft and also go back and read my presentation from previous IETF. If things don't make sense to you, find me or send an email on the mailing list. But just
so we will have the question on Thursday, and the continue this interesting stuff on them.
Very short comment. I think maybe out of design team, there needs somebody to review this document before adoption.
So let me point some things out. So these are working teams. They have been working openly. Anyone could join these working teams. They were fully open. And all these documents are in par of any other individual document. These are just interest group of people working together, and they put together a document. So they are not really a design team products. They are bunch of people with the same interest working on something and posting that.
Yes, I agree. It is good to have open working teams and open audio conferences, and phone calls were announced on the email list, and this is very good. On another hand, it is at the meeting at IETF that decisions should be made, right? And we should not be somebody who has not participated to the audio conference.
So let me explain again. It's the fault of the individual who didn't want to. Alex. So it's an open process. If someone doesn't participate, open process, it's his own or her own fault. And then all these, anyone can propose the same, exactly the same document on the same area and ask for an adoption. They have been meeting like 4 times, posted the minutes on the mailing list, said that this is what we discussed and so on and and now they just went and asked for the adoption of the document. Anyone else could have done the same. Propose a document and ask for a presentation time and so on.
It is open, but it has no more legitimacy than discussion at this
Of course not. And that's why everything will be handled here on the mailing list and in the meeting that we have. So it will be run through like any other individual document. There's no difference on that. The reason why we actually ended up with this process is like that is to reduce the amount of documents on the same topic. If people are anyway going to work on these things, so why don't they would do that in a kind of in advanced working together than bidding for other documents? That's the only reason. Okay, so I was glad to see that we actually had some heated discussion. This is excellent. So on Thursday we have 2 hours, and we continue there and make some great movements on Thursday. So see you on Thursday. Bye.
Do you think it's
That's 1 hour.